Okay, so the other major thing that we really have to talk about in this chapter is something called density. And you've probably had this before in physical science, middle school, that kind of thing. So density is calculated by taking mass divided by volume. So it's not just a matter of how heavy something is, but people tend to use it that way. What it really is it's a matter of mass per volume. So you could have something with a relatively large mass, but if it has an enormous volume, it's going to have a pretty low density. So it's not a matter of how heavy something is, although people do use that pretty interchangeably. With regards to D, the equation is D equals m over V. The units that we're going to run into most often are grams per milliliter. But if you're talking about gases, gases tend to have very low densities. So in order to have like normal numbers, they use grams per liter. You can rearrange this equation. If you multiplied both sides by V, you would get m equals VD. Or if you rearrange this by dividing by D on both sides, then you would get V equals m over D. Okay, so whatever you'd like, it doesn't really matter to me personally. I prefer rearranging numbers over rearranging letters when I do stuff, but if that floats your boat, go ahead. And I can give you any two of those three variables and ask you to calculate the third. Okay, we're going to start simple though. The one thing you want to make sure that you do it, when you do it, is that the units that I give you in the problem match the units that are given for density before rearranging, because it gets ugly after that. So it's much easier to rearrange the units before using the D equals m over V than after. So for this one, you have a volume. You need to recognize that as being volume because it's got liters. And you have a mass, and again, recognize that as mass. Calculate the density. D equals the mass, 35.062 grams over 23.50 milliliters. And your calculator is going to spit out 1.492. Units are grams divided by milliliters, or grams per milliliter. Right here is the unit. In terms of sig figs, 4, 5, that is the answer. It has 4 sig figs. Okay. Mercury has a density, so I'm giving you the density. And again, notice the units. The units tell you an awful lot of stuff. Determine the mass of 12.75 milliliters of mercury. Well, I want to make sure before I do anything that this unit matches the volume part of the unit for density, and it does. So in that case, all I need to do is literally plug it into D equals m over V. Here's my D, 13.6 equals the mass, I don't know what that is, I'm looking for that, over 12.75. So put this over 1, do your little cross multiplication thing. You get 173.4. I'm going to talk about units before sig figs. So with this one, you want to find out the correct unit. Now you may know that the unit for mass is grams. The other way you can tell is you look right here at the units for density, because the units for density tell you an awful lot. Grams per milliliter. So the milliliters match, that means the mass has to match. The unit would be grams. In terms of sig figs, this has 3, this has 4. My answer needs to be 173 grams. Okay. Carbon dioxide. Now carbon dioxide is a gas, so notice what my units are. Okay, again, pay attention. It tells you an awful lot. Has a density of 1.562 grams per liter. Determine the volume, that's what I'm looking for, of 22.3 grams of carbon dioxide. So I want to make sure that my unit for mass matches the corresponding unit inside my density, and it does. So again, all I have to do is plug and chug. 1.562 is the density, equals the mass, 22.3, over the volume, which I don't know. Okay? But again, you want to make sure you set it up properly. You have to know what things are. Density, and this is mass, and you're looking for volume. Set this up and cross multiply. You get 1.562x equals 22.3. X is therefore 14.2765685. In terms of sig figs, That's got 3. That has 4. So my answer is 14.3. Okay, now in terms of the units, again, go back to the original density because that tells you so much. The liters right there tells me that the unit for volume is going to be liters. Okay, one other thing I do want to point out about this problem. When you set up the algebra like this, very, very often people are tempted to do algebra that is not correct. Okay, if you struggle with algebra, you absolutely should write stuff like this down so that you know that this is the correct solution, that you end up dividing the two numbers. Okay, make sure you know how to do algebra. Okay, it's basic 9th grade algebra 1. It's not hard, but you do need to know how to do it properly, particularly when you're solving for a unit or an unknown in the denominator. Okay, so it'll be easiest to solve these next problems if you make sure that the mass units match whatever the top unit is of density and the volume matches the bottom before you do D equals M over V. So calculate the density in grams per milliliter. So this is what I'm looking for. If it has a mass in milligrams and a volume in liters. So before I solve this problem, before I do D equals M over V, the first thing I'm going to do is I'm going to take that mass, 354 100 milligrams. I'm going to do a conversion like we did before, and I'm going to make sure it matches the top unit of density. 1 milligram, e to the negative 3. So 354.1 grams. Volume, 8.65 liters. Again, I'm going to make sure my volume units match the units that are given to me as density, which means I'm going to change it from liters into milliliters. 1 milliliter, e to the negative 3. Again, milli, that's what it means in both of these cases. Coincidence that it's both millis on that case. So 8,650 milliliters. So now, to find the density, I've done the conversions. The units match what I want in density. So 354.1 grams divided by 8,650 milliliters. You get 0.040936. Okay, units are grams per milliliter. Make sure you include those. In terms of sig figs, when it comes to sig figs, you go back to the original problem. You don't look at what you've done here. You go back to the original problem. That has 3, that has 4. It means my answer is 0.0409 grams per milliliter. Okay? All right, so go ahead, take a couple of minutes, make the conversions first, because we're looking for a mass in grams. Okay? Well, that unit matches the top part of the density. But if I'm looking at my volume, it doesn't match. So before I do anything else, before I use D equals M over V, I'm going to do 8.29 e to the third microliters, and I'm going to change it into milliliters before I do anything else. So go ahead, practice this, see if you remember how to do it. Pause the movie, whatever you need to do. Okay, so to make this conversion, microliters on the bottom, liters on top, put a 1 where you see 2 letters, e to the negative 6, gone. Liters on the bottom, milliliters on top, 1 by the 2 letters, e to the negative 3 for milli. So when you do this, you get 8.29 milliliters. Okay. Then to do the mass, you're going to use the density, D, 2.961 equals the mass over the volume, which we just calculated to the correct unit of milliliters. Put this over 1 again, do your cross multiply, and you get mass equals 24.54669. But in terms of sig figs, you go back to your original problem, 3 and 4. So 24.5 unit would be grams because it matches the top unit in density. Next one, you want to calculate the volume in milliliters, which matches the bottom unit. but you need to make sure that the mass matches the top unit, and it doesn't. So what you need to do first is do your conversion. And you need to change it into grams so it matches the top unit for density. Kilogram on the bottom to cancel, put a 1 where you see 2 letters, base unit on top, kilo means e to the third, so 0.835 grams. I'm giving you the density, so D equals M over V, 8.45 equals the mass, the new correct mass in terms of units, over the volume. And again, you're solving for something in the denominator. Take your time on the algebra, okay? Do it properly. Might as well learn how to do it now. If you didn't learn how to do it in Algebra 1 or you've forgotten, now's the time to figure this out because you're going to be doing it a lot. And the volume is 0.09881656. So in terms of sig figs, 3, 3, 3. Sorry, I went back to the original number, 3 and 3. So that's correct, and then the unit matches the bottom unit, milliliters. So it's really important to pay attention to units. Units can tell you so much about what you need to do. It's almost like they're a roadmap for how to solve problems. Okay? Also, be real careful with your algebra, particularly in problems like that where you're solving for something in the denominator. Okay, a lot of people make that mistake. I did write it out specifically to make sure you guys kind of see how it's done. Practice it. Okay, and then the last thing, watch out for sig figs and units because I will absolutely keep track of that.